Okay, in the last video, I showed you how I made my table by just plugging into my calculator. So I did 1/2 times 3 to the -2 power plus 1, and I got 19 over 18. That was a little bit more than 1, so I graphed that. I did the same thing, but just changed this -2 to a -1 in my calculator, and that's how I got 7 over 6, which is just a little bit bigger. Then I got 1.5, I got 2.5, and 5.5. That's enough points for me to see what's going on here. Okay, so 25 says, does the graph represent growth or decay? How do you know? So since this graph is increasing from left to right, it is going to be growth. I'm increasing from left to right. Another thing that can tell me it's growth is this 3 right here, that my value of 3 is greater than 1, and that's another reason why it's growth. If it was less than 1, or actually between 0 and 1, call that our B value, that would be decay. Something like a half or a third or 2/5, something like that. Just because it's a fraction actually doesn't mean it's decay. Something like if this was a 3 over 2, that's actually 1.5 bigger than 1, so that would be growth as well. Okay, what are the x and y intercepts? Well, we actually don't have an x-intercept. So x-intercept is none. Y-intercept we can find in our table. We can find on our graph. That will be 0, 1.5. The next question asks about the equation of the asymptote. So you can see that our graph kind of almost flattened out here at 1. And that is going to be our asymptote. It's the line that our graph is approaching as our graph gets more and more negative. Horizontal line, so it's y equals. Domain and range. So because of these arrows mean that we're going to continue in this direction infinitely, and we're going to come up and out forever and ever and ever. So because we're going to the left forever and ever and ever, and we're going to the right forever and ever and ever, my domain would be all real numbers from negative infinity to positive infinity. Or we could just write out all real numbers. Now our range definitely has a lowest point. It's 1. It goes up and up and up forever and ever and ever. So that's infinity. Now on the range on, let me scroll up a second. The range on number 3, we had like this, where it was -2 is less than or equal to y is less than infinity, because we actually come down here and touch this -2. On the exponential, we don't. You don't actually ever get to 1. If I look in my calculator, I have the table pulled up right here. I graphed the, hold on, let me bring it over. I graphed the equation, and I'll show you how I did that. So I went to new document, and I went to graph, and then it was 1/2, 3 in parentheses. My exponent was x, and then I had +1. That's my graph. Control T will pull up my table. And there's all my values that I graphed. So if I continue to go more negative, I see that it looks like it's saying 1, but if I look down here, it's giving me some more digits. It's actually 1.0000000, whatever, 348. And as I keep going, these numbers get smaller and smaller and smaller and closer to 1, but I actually never exactly get all the way down to 1. There's always going to be some other digits over here, because no matter how small this fraction gets, it's never going to become negative, and I'm always going to be adding 1 to it. So I've always got to be a little bit bigger than 1.